So a triangle has these vertices, ABC, and MN are the midpoints. Show that MN is half the length of BC. So we do need to find the length of BC here. Should we do that first? So BC, again, I could just write BC, or if I do it in vector notation, I'm looking at the length of the vector BC. So we would go square root of, let's look at B and C. So we've got 1 minus 1 all squared for the x's. For the y's, minus 5 minus 3 all squared. For the z's, 7 minus 3 all squared. So there we have 2 squared, 8 squared, and 4 squared. So that is 84 under there. 84 is 4 21s, so that's 2 root 21. Alright, so that's BC, and we are trying to show that MN, is half that length. So we better find MN. Well, in order to find MN, we need to find MNN first. So M and N, let's just write them. Actually, I don't even need that. I'm just going to write the midpoint down. So I won't do all the working. The midpoint is, so M, I'd advise you to do it, is the midpoint of what, A and B. So I'd do a bit of working there, but we can do that in our head as well. So we're going to go 3 plus 1 and halve it. We're going to go minus 1 minus 5 and halve it. So we're finding the averages each time, and then we're going to go minus 3 plus 7 and halve it. So that's M. Let's have a look at N. So for N, we are doing the midpoint of AC this time, so don't get confused. So if I'm looking at A and C, I'm going to go 3 minus 1 and halve it. We can go minus 1 and 3 and halve it. Oh, same. And minus 3 and halfway is, of course, 0. So there's M and N. So now we can find MN. So MN, distance. If we have a look at that. So we're doing 2 minus 1 squared, 2 minus 1 squared, minus 3 minus 1 squared, and 2 minus 0 squared. So what have we got there? A 1, a 16, and a 4. So we've got a 21 there, which is clearly half of, because the other one's 2 root 21, half of 2 root 21. If I write it like that, then I'll make it really obvious. Sorry, I'm just going to go over here for my working, which is clearly half of the length of BC. So we have shown that MN is half the length of BC.